All right, here we go. Continuing on to the molecular nomenclature assignment. This is the one that I think students actually struggle with the most. Aside from doing the charges on the chemical formulas one, it's pretty straightforward. But here, sometimes the syntax is not obvious. So we're going to go through a few of these together. What is the IUPAC name of CABR underscore or little 2 there? So when we are naming compounds from their formulas, we have to identify the type of compound it is to know the type of chemical name it's going to get. Calcium, from our periodic table, is a metal. Bromine is a nonmetal. Combinations of metals and nonmetals makes ionic compounds. Ionic compounds have different rules than molecular compounds and different rules from acids. And so identifying that it's an ionic compound tells us which set of rules we're going to use. Thankfully, this is the easiest of the sets of rules. You simply need to state what the first element's name is, and then change the suffix of the second element's name to IDE. If the first element is in the main group, that is the first two columns, and then all of this big chunk over here, then you don't need to include a Roman numeral to represent the charge. If, however, it's in this smaller section in the middle or the little cutout down below, that means that you do need to use a Roman numeral because those groups have variable charges. So keep an eye on that when you're naming your ionic species. Here, I'm just going to call this calcium. Put a space in between the two names. And then bromide. So it was bromine. I dropped the INE for an IDE. Unfortunately, this is one of those things you're just going to have to get used to. Look at some references. If you get the spelling wrong once, take a look online and see how other people do it. It's not always obvious, like oxygen becomes oxide. You might not have predicted that the first time you saw it, or phosphorus, you might have thought phosphoride, but it's actually phosphide. So just spend some time getting used to how those spellings work if you get it wrong the first try. Again, you do get 5 attempts before you start losing any points on these, and then 5 more attempts after that to actually get any points. So hopefully that should be plenty of space for you guys to correct any small spelling errors. Yay. Okay. What is the IUPAC name of V, parentheses, OH, close parentheses, 5? You want to take note of how many elements are present in any of these compounds, because that's a really good indicator of what type of compound it is. I count 1 for the V, 2 for the O, and then 3 for the H. There are 3 elements here. If there are more than 2 elements, then you have a polyatomic ion somewhere in your compound. We're going to try and find V on our periodic table. V is for vanadium, and it is a transition metal. Because we know this is a transition metal, that means that I have to worry about the charge that vanadium is going to make. I'm also going to be looking for this polyatomic ion. I can tell this part is the polyatomic ion because it's in parentheses here. Your parentheses are only going to be used around polyatomic ions, at least for this homework assignment. So I'll head over to my polyatomic ion reference sheet and look for that OH minus. And here it is. We have hydroxide. So I need to figure out what the charge of the vanadium is and then write out the name. So I'll head over to Notepad, and we're going to figure out the charge on vanadium by figuring out the charge on all of my hydroxides. And so vanadium has a variable charge. I'll just write it as a V for now. And then we had OH, which had a -1 charge, but there were 5 of those. So because there were 5 -1s, the only way to balance that is to make sure that we have 5 positive charges. The way we're going to do it here is we're going to say that we have a vanadium 5. And so I'll put a +5 charge for my vanadium. And then when we're writing the name for it, we're going to indicate that it's the +5 by using Roman numerals. When typing the name here, make sure you spell it right. It gives you a little clue sometimes there. So vanadium, there is no space in between vanadium and its charge. So I put the parentheses, I put the uppercase V, I close the parentheses. Now, just like we were doing previously, we are going to put a space in between the two different elements, or in this case, between the element and the polyatomic ion, and this is now hydroxide. Moving on, we have Cu subscript 3N. So there are only two elements here. One of the elements is a metal. I know that because copper is metallic. We use it all the time. We see it in our daily lives. Also, you could look at the periodic table and figure out, hey, it's not in that top corner. So this is a metal. And nitrogen is a nonmetal. A metal and a nonmetal make a ionic compound. So we are going to figure out first what the charge of those things is. Copper is in the transition metals. It's this section in the middle of the periodic table, which means it has a variable charge. We'll need to use a Roman numeral with it. Whereas the nitrogen is a nonmetal, it has a predictable charge. You just count the number of spaces away, 1, 2, 3, minus. The nonmetals will pretty much always make minus charges. And so I'm going to use that information to figure out what the charge and subsequent Roman numeral of my copper should be. So copper is a question mark to start off. Nitrogen, though, prefers to make a -3 charge. And so, because I have 3 of those coppers from the chemical formula they gave us, I'm going to figure out what charge copper would need to have to balance the 3 minus from the nitrogen. And to balance -3 with 3 coppers, you would need a +1 for the copper there. And there you have it. We know that copper now must be a +1 charge in order for this compound to be balanced. So I'll go back over here, and we have copper, writing the name out, copper, open parentheses, and we need a charge of 1, so I'll use a capital I, I'll close the parentheses, and then we'll just put the nitrogen. Or sorry, it's not nitrogen here because it's a binary ionic compound, so it'd be nitride. Let's try one. They're all so good. Now we'll do this one. SF6. And so I'm going to figure out what type of compound this is by looking at my periodic table, and I see sulfur here, and I see a fluorine there. So sulfur and fluorine are both nonmetals, making this a covalent or molecular compound. These are the easiest to write the name for because you just need to know how many of each element, and then use the Greek prefix to specify how many there were. This is going to be sulfur space fluor. See, even I mess up sometimes. Always check. Fluoride here, and we have 6 of them, so it'll be hexafluoride. Let's try another one like that. SiO. I find silicon here oxygen there, usually the nonmetals and the metalloids will still make our covalent compounds. So we're going to name this using those Greek prefixes. So this is going to be silicon monoxide. Let's try some acids. We already saw that this one in the last video was hydrochloric acid. We included the hydro because it was binary. What about this guy? Which type of acid is this? Well, first of all, you can tell it's an acid because it has the H that it's starting with. I can tell it's a polyatomic acid because we have 3 elements in total here. 1 H, 1 chlorine, and 1 oxygen there. When you're naming your polyatomic ions as acids, you want to first identify the polyatomic ion, convert its suffix into the corresponding acid suffix, and then just write that down. Don't include the hydro in front. Hydro is only used for binary acids. So I need to find out what ClO4 is. Looking at our reference sheet, ClO4 is perchlorate. So that 8 suffix, that's what we're going to be modifying when we draw this as an acid. The general rule is that the suffix of 8 becomes ic acid, and a suffix of ite becomes us acid. And so, because we had perchlorate, just going to redo that. Forgive the terrible handwriting, which is exacerbated by drawing on this weird tablet thing I have. Perchlorate was the polyatomic ion. I'm dropping the ATE and replacing it with ic acid. And so the full name would be perchloric acid. Make sure you put a space in between the ic and the acid. So perchloric acid. I think that's all of the major types of these different problems. If you have any questions, if you have any confusion, please come to my office hours. Office hours are on the front page of our Canvas course. So they are Mondays 11 to 12, Wednesdays 4 to 5, Thursday from 9 to 10. So there's 2 more office hours in between now and when this assignment is due. Or shoot me an email. I'm pretty quick to respond to emails, and I would love to help you guys out. Just include a screenshot of your attempt, and it'll be very easy for me to diagnose the problem. Thanks so much, everybody, for your hard work. I hope that you found these videos helpful, and let me know if there's anything else I can do for you. Thanks.